Okay, guys, welcome back. Announcements first. Today is the due date for your assignment, so please do not forget to submit. You still have a couple of hours. Very simple, one page, a PDF with a use case diagram that corresponds to the system that I asked you to review. So one people in your team submit, only one person submit, and please be sure to add the names of everyone that participates, so everyone received the same grade. Don't forget that. Second, we have only done one quiz. Another quiz is coming. Next lecture, a quiz. I am giving you the announcement because it's a quiz all about requirements. Easy questions, but the idea is to evaluate your knowledge about all these things that we have been talking about: requirements, functional, non-functional, the diagram, use cases, activities, and state, and the difference between them. So my advice, review that material. If you haven't done that yet, review the slides, the videos of the previous lectures. That is what we have been doing. Review everything, be prepared for a quiz. Even though the quiz is open book, as you know, you have 30 minutes, 20 in fact. So in 20 minutes, a lot of questions. It is better if you review things before. Good. So assignment 2, quiz 2, your work for today, for this week. Moving forward. Okay, we review the Pac-Man. I asked you to review the game of life. I asked you to review the final project of 360, 3 systems, games, working with data, whatever. You should be experts identifying requirements. And now we can talk about every single one of these, every single oval in these diagrams is one requirement. The details for the requirement, maybe in another document, maybe in a diagram, activity or state, but each of these things is something that needs to be done in the software in order to have the system that the customer is asking for. Next step, I have this. I have a correct use case diagram. I have a collection of stories. I have my requirements. What I do next? What I do in order to complete my Pac-Man? Well, easy. If you have your requirements, now if we're going to work with the object-oriented paradigm, if we want to program this with an object-oriented programming language, my next step is moving to objects. Objects, classes. I need to move from my requirements, from these ideas, stories, or this diagram to a collection of classes. And I am going to use that classes to create objects, and I am done. What I need to do in order to move from here to classes. That is something that we need to review. Now, moving to classes, some concepts for your quizzes. 3 concepts. You know, object-oriented programming. Object-oriented programming. Programming in the object-oriented paradigm. Programming with classes. What you do with Java, object-oriented programming. Very different than what you do programming with another language. C. You do not create classes, you create another thing. Lisp. You do not create classes, you create other things. Object-oriented programming. Implementation with classes and objects. But in order to do object-oriented programming, the previous step, object-oriented design. And the previous step, object-oriented analysis. I am talking about analysis, design, and programming, but the 3 of them with this idea that we are in the object-oriented paradigm, that everything that we're going to be talking about is classes and objects, classes and objects. This is used because we want to implement the software with an object-oriented programming language. Most of the programming languages are object-oriented. It's easy to do design and analysis thinking about objects. So object-oriented analysis. Object-oriented analysis, the first thing that we're going to do, from requirements to classes and objects. Classes and objects in analysis. I am talking about identify which are the classes that we need and how many objects we're going to create from each class, period. This is the problem. Tell me how many classes do I need. I am not asking for the implementation yet. It's just tell me how many classes, maybe the name of the classes, maybe what those classes you think they are going to have inside. Use an idea. Use moving from here to here. You can think about your first draft of what is going to become your class diagram. Use a first draft. Just tell me which classes do you think we need and what they are going to do and how many objects from each class we're going to create. Classes and objects. Next, after we have an idea, a draft, after we do the analysis, after we identify those classes, the next challenge is to connect the classes. Class A, class B. We identify them in analysis. Next, they are going to be connected? Yes or no? If they are going to be connected, which is the connection that we are going to use between them? How we are going to connect them? Help me. I am going to review this later, but just to give me an idea. How many different types of connections do you have between classes? Which options do we have to connect two classes from 360? Connections between classes. What can I use?
Composition and inheritance.
Ideas? Nothing? Two classes, A and B, they can be connected by inheritance, for instance. One class can be the father and the other class can be the child. That is one connection, inheritance. Composition. One class can have a variable from the other class. And the last one, inheritance, composition or aggregation, and one more. Association. One class, yeah, thank you. One class can call a method in another class. Those are the three connections that we can have between classes. I am going to review those a little bit. So you identify your classes and then identify the connections. And identifying the connections is all about design. Remember, design, create models. What is a model? The elements connected, the elements and the relationships. Talking about object-oriented design, the elements are the classes. And the only thing that we need to do is which are going to be the connection between the classes. And we have only three options for the connections. So nothing, or inheritance, or composition aggregation, or association. We need to decide which one of those four options we're going to use between the classes that we identified before. And that's it. Finally, we have the model, the class diagram. Do the programming. And let me be clear, if someone gives you a class diagram is like the blueprint of the house. The only thing that you need is workers to put together what the diagram is telling you, and the software is done. So you have the use cases for the Pac-Man, and you have the use cases for the Game of Life, and you have the use cases for the final project of 360. If we work and identify the classes there, and we work together and identify the connections, I can ask you to do the implementation. With the blueprint, you can create a Pac-Man video game, or the Game of Life, or the final project. Hypothetically, yes. Let's see if that works. That is the next assignment, maybe. Okay, object-oriented analysis. Requirements to identify classes and objects. Design classes and objects, connect them, create a model. Programming, coding, object-oriented programming language, and do the software, compile and run. Parentheses. 360, again, I need to be sure that you know this. Class diagrams. Class diagrams. Number one. Do we agree that in a diagram, a class is these rectangles? All the rectangles that I am showing you on the screen, they represent classes. That if I give you this shape of a rectangle and I ask you to do the programming, each of these rectangles basically represent what in the source code is class, the name, and the curly brackets in a particular file. That is the equivalent in source code of any of these rectangles. Now, being more specific, can we agree that the rectangle have three different parts? The most important and the only that is mandatory is the top one. The top one is the name of the class, the thing that you need to put here in the source code. And then you have a space here and a space below, 2 bars, one for the variables, the global ones, and the other for the methods, just like that. The variables, you know what to do with them, and the methods, you know what to do with them. The content of the class. The picture of the class in a diagram is just a rectangle, and you put there the name, the variables, the methods, you are done. Important thing for the classes. Do you remember that I can put here something like a minus, or I can put here something like a plus, and they represent something? What is the meaning of the minus? What is the meaning of the plus if I ask you to translate to source code?
Public and private.
Public and private. Good. Exactly. The access identifier. Good. Perfect. So rule, usually 80% of the time, the rule is your variables are going to have the minus. Your variables should be private. There are exceptions, as usual, but usually your variables are going to be private. Your variables are going to have this minus. Your methods, not all of them, but some of them should be public, the interface of the class. So when you read a method name, usually you're going to have more pluses below than above. Above, you're going to have more minus than pluses. Good. The classes are easy. The only complicated part, the plus and the minus. The interesting part is the connections. The connections. You told me before that I have options between two classes, and what I can do is inheritance, composition, aggregation, and I can do association. Do you remember the representation of these 4 ideas in the class diagrams? For instance, I have those 2 classes, and I want to tell that one is the parent of the other. The representation of inheritance in the class diagrams. Solid line with an empty triangle as an arrowhead. I need you to remember this. In UML, inheritance is this triangle here, empty. The arrow in PowerPoint, that is not inheritance. That is an arrow in PowerPoint or whatever. It's not part of the representation that we use for classes. Help me, if I do this, which one is the parent? A or B?
B.
A, B.
B is the
Question in your
parent.
exam, A, B, both, none. How do we know which one is the parent? always, the arrow is pointing to the parent. The one that have the arrowhead, that is the parent. In this example, the parent is B. Why? Because of the arrow. The arrowhead is pointing to the parent. Now, question in the chat, very important. We're talking about inheritance in general. However, connected with the idea of inheritance, there are two concepts. Concept number one, generalization. Concept number two, specialization. Specialization is to put a child to a parent. Specialization is, you know what? I have this class and I am going to create a child. If I do that, create a child from a parent class, what I am doing is specialization. The opposite, I have this child, or maybe these two, and I want to create a common parent for them. So these are two classes, separate, alone, and I want to connect them with a new class. And this new class is going to become the parent. If I do that, what I am doing is generalization. Specialization, create childs. Generalization, create a parent. Example, in Java, if I ask you to do a program in Java, and I ask you that program in Java to have a window, it's going to be a program like the Pac-Man, and what? You need a window to put inside the application. What do you do in programming in order to create in Java an application that have a window? I have that class game that I am going to ask you to create, and I want that one to be the graphical user interface for my game. I want that one to be a window on the screen using Java. If you have done that before, if you did your final project in 360, something similar to the one that I asked you to review, you know that in Java, what you need to do is to use inheritance from a J something class. In particular, I am going to use this one from the swing. Game is the application that I want to do. Game is the class that I am asking you to create. GFrame is one class from the Java API. In order to create a graphical application, one of the first things that we do is use inheritance and connect my class with one of the classes from the library. Tell me, the arrow is going to be inheritance, like that one. The arrowhead is going to be pointing to game or to JFrame, according with my explanation of what do you need to do. Good. I am telling you that JFrame is a class that already exists, and I am telling you that you are going to create a child, and that child is going to be game, and it's going to be an extension of JFrame. If we talk about the source code for this, what you are doing is a class, public, class, game, and I am asking you to do extend JFrame. That is the source code for that picture. Your project manager, myself, I do not need to tell you, write this. The picture is telling you to do this. Your new class is a specialization of JFrame. Talking about the concept, game is a specialization of JFrame. It's a child of JFrame. JFrame is a generalization of game and several other classes that use that parent in order to create graphical user interfaces. Makes sense? Now, there is a particular case. There is a particular case in Java in which instead of doing extend, there is another keyword. Implements, like help me, in Java, what is the meaning or the use for implements? Inheritance is between classes, right? Implements is also inheritance, but is inheritance not from a class, but from an abstract class, from an interface. Tell me, what is the difference between a class, a normal trivial class, and an abstract class or an interface? Okay, you have the idea. Key idea, guys. The interfaces or the abstract classes have the signature of the methods, but usually without a body. Think about it. You have a class. Your class have variables, attributes. Your class have methods. And when we talk about methods, is the signature, the parameters, the name, the return type, and they have a body, something inside of the open and closing curly bracket, right? Because they are doing something. Classes have methods with bodies. Interfaces or abstract classes, usually, yeah, they have methods. Well, empty methods. Empty method, yeah, they have the method name, the parameters, probably the return type, but the body is missing. Yeah, that is the name. So when you have these classes that are not complete, when you have these classes in which the methods do not really exist, do not have a body, they are just skeletons of a method, what you do is to create or to put them in what you call an abstract class. An abstract class, yeah, these classes that cannot be used to create objects because, well, they have content that is not complete. There is a good reason for doing inheritance from those kind of classes. One of the reasons is because, well, in the interface, in the abstract class, you have the signature of the method, but you do not have the body. And in the child, you are inheriting that empty skeleton. In the child, you're going to complete the skeleton. In the child, you're going to put a body to the method. We're going to review that. The only thing that I need to do here is just imagine that you have this class here that is an interface or an abstract class. One example of an interface the listeners in Java, the action listener, the mount listener. They are interfaces, and you want to do inheritance from them. You use implements. When you use implements, your class diagram, your diagram is going to change. Still, this is going to be the parent. Still, you are going to use the triangle, but the line is not going to be solid. When you saw a diagram and you have inheritance, the triangle, and you saw the line solid, that means that both are classes, game and frame, they are classes. You are doing extend in Java. You are doing inheritance from a class. When you have something like the dot line, with in blue, what you are telling the reader is, hey, I have inheritance here, but the child is a class. The parent is not a class. It's an abstract class, it's an interface. Any of those options. So some of the methods here do not have a body. One of the responsibilities of this child is going to be complete the bodies. Makes sense? So all this to tell you, inheritance. Inheritance, the important part is the triangle as an arrowhead. White triangle, never black. A triangle, nothing inside. It's going to look like white in your papers or in the screen. Solid line, inheritance between classes. Dot line, inheritance from an interface. Good. Next, composition and aggregation. Composition and aggregation, tell me, what is the representation in UML of those relationships? What is the representation in UML of aggregation or composition? How do you identify a composition or an aggregation in UML diagrams? The diamonds, correct. You identify inheritance because you have the triangle, and the triangle is always white, period. You are going to identify composition or aggregation because diamonds. Because you are going to have a class, and it's going to have the diamond, and it's going to be connected with another class that do not have anything, or well, it could have an arrow like that. A class, the diamond, nothing, or it can have an arrow. What does it mean, composition or aggregation? What is the meaning of this diamond? This is what in the requirement was the include. And this is this idea of, you know what? I have this car as a class, and I have this engine as a class. One has the other, having. That is the idea of composition and aggregation. Having. The diamond is going to be with the class that is the biggest one, with the class that is the owner of other things. In my example, the car is the one that has the engine inside. The car is the one that is going to have the diamond. The others have nothing. Now, the next question. The diamond black, the diamond white. For those of you that take 360 in the previous fall, you know the difference. I just want to be sure that everyone is in the same page. Diamonds, black versus white, the difference. Black is composition, correct. This one is called composition. The other is going to be called aggregation. And what is the difference between composition and aggregation? The big difference. If you connect two classes, and those two classes are connected with a diamond in white, a wall relationship. Yeah, somehow. If you use the diamond in white, exactly. This element here is optional. The diamond in white means that the thing that is inside of the main class is optional, can be there or not, can be null, and we are okay with that. if you put the diamond in black, what you are telling is that element should be part of the second one and cannot be null, never be null. Because if the value is null, this guy do not exist or cannot exist. Diamond in black, the element cannot be null. The element that is in the opposite part of the diamond. Diamond in white, the element, the one in the opposite side, can be null. Oh, both are independent. Both classes, and that is something that we need to review, they are independent. I am giving you this example with car and engine. They are independent. You can have a car, you can have an engine. They exist separate. They can be done by different programmers. Independency is going to be a key idea between classes. We need to talk more about it, but these two are independent. The point is the connection. The connection is for car and engine. What would you use? I use both for the same. Which could be the correct relationship between a car and an engine, aggregation or composition? Maybe I could ask about another class, wheels. What should be the relationship between car and wheels? For sure they are connected. And hopefully you agree with me that there is going to be a diamond here also. Notice, car is the one that have the diamonds. The one that have the diamonds is the owner. Car is the owner of the wheels. Car is the owner of the engine. Diamonds are relevant. The diamond tell me who is the important class. The triangle tell me who is the father. Here, the diamond tell me who is the owner. The only thing that I need to decide is whether or not to use black or white. Can be null or not. Whatever option you take, the important thing is to be able to justify. The usual answer for this in the books is as follows. The connection between car and wheels is aggregation. Why? Because the wheels can be null and the car is still a car. You can have a car and in some point remove all the wheels and everyone still is going to think, oh, that is a car without the wheels, but that is a car. Looks like a car, works like a car, is a car, but in some point the wheels are null, are not there. You can aggregate the wheels later, change in real time during the life of the car, the wheels. Regarding the engine, usually when we think about a car, if you have something that is a car but you open and it do not have an engine, most of the people, again, it's like, well, this is not a car. Cannot be a car if do not move, do not do the operations of a car. The engine is a key part of the car. Moreover, usually the car is born with the engine. You do not go and buy a car without the engine and later you buy an engine and put the engine into the car. Again, I am talking about common scenarios, right? So the car is born with the engine. The engine cannot be null. The engine is mandatory. And in order to represent that, we put the black diamond. Cannot be null. The car cannot exist without the engine. It's mandatory for the car to have the engine. Cannot be null means that it's going to be created in the constructor of the class. The constructor of car is going to create the engine. And during the full life of the car, the object is going to have an engine. Opposite with the wheels that are going to be removed or aggregated later. Well, and the different scenarios that could happen, right? This is the key idea. Both are related with having something. The color tell me if that is having temporal null? Can I wait to have that? Yes or no? Is mandatory for the owner to have it? Maybe the owner stop being a car or stop being whatever just because that element is missing. That element is really, really important. Black diamonds, white diamonds. In the examples here, library and books. And I want to ask for your help between the library. Any of the libraries in ASU, they have books. There is a relationship between books and libraries that need diamonds. The question could be white diamond or black diamond. Oh, okay. You tell me the answer. The library, any of the libraries around the campus, stop being a library, is not a library anymore if we remove all the books. And suddenly you have this idea like, well, I can have a library with 0 books. And I think that that is true. Again, the important thing is if that is our idea, that the library is going to be still the library, even though the library do not have books, in order to represent that idea in the class diagram, this is the notation that I choose. Again, if what we want to communicate is the library can still be the library can be there without books. And if you think about the books is something that we aggregate to the library later. We first build the library and then we can insert books. So aggregation makes sense. Well, that is a different story, but yeah. It can be any room. Okay, guys, these are decisions that you are taking. We're going to review the software, the systems, but this is the decision that you do before I start programming is tell me, you're going to have this variable inside of this class, can be null or not. That decision, you sign your decision when you put the black or the white diamond. That's it. Now, the other thing that you can have connecting classes is use a line. And that line could have, if you want, arrowhead with only lines. Notice here, I do not have a triangle, and I do not have any crazy arrowhead. It's just a line, and if you need to mark the direction, 2 lines as an arrowhead, the trivial arrowhead. That one represents association. Tell me, what is the meaning of association in your source code? Inheritance was this implement and extend. Aggregation, composition, we're talking about variables. What about association? What happened with this one and this one in the source code? What is the meaning of association in the source code? Any idea? Call a method. When you connect to classes with this or this, what you are telling me is one of the classes is going to call a method in the other class. That is association, calling a method. If you connect airplane and passenger like that, what you are telling me is one of the methods in the class airplane is going to call one of the methods in the class passenger. What is going to be the result? What is going to be the method? Which method? I do not know, but that is what you are telling me that is going to happen there. Calling a method. 3 relationships. Calling methods, fancy name, association. Creating a variable. I am talking about global variables. Fancy names, composition or aggregation. And inheritance, extend or implement. Those are the only things that you can do with your classes. In fact, those are the only things that you can do in the source code. to connect to files, to classes. Okay. What is the meaning of this line here, connecting the class with itself? Is possible? What is happening inside of that class stuff according with all my explanation? Not necessarily recursion. Be careful with that. It could be recursion, but not exact, is not mandatory. The line means that a method in one of the classes is calling a method in the class that is in the opposite part of the line. Here, in particular, a method in the class staff is calling another method in the class staff. A method in one object in the class staff is calling a method of another object in the class staff. It's not just any method. It's a method connecting objects. And recursion could be a case. We need to review it. But every single time that you look a line that is connecting the class with itself, something is happening there with the objects. There are objects of that class communicating, and it's going to be very useful for something. It's not recursion. Just be careful with that. It's not always recursion, because these are classes, not methods. So it's not always recursion. Very good question. Guys, if I put a line and I do not put arrows, the meaning of that is, for instance here, that there are arrows in both parts. When you have a line without arrows, the meaning is bidirectional. The line without arrowheads is bidirectional. And the meaning is, as you mentioned, if I connect this passenger and airplane with the line, I am telling that passenger can call methods in airplane and airplane can call methods in passenger. I am mentioning or drawing that the connection is bidirectional, like one can call the other and vice versa. When you put the arrowhead, what you are doing is removing that possibility of two directions and establishing that only one direction is possible. In the second example, I am telling airplane can call passenger, but passenger cannot call airplane. So no arrows, bidirectional. Good. Okay, so yeah. If I have that, the translation to that source code, I am going to have a method here, method, and I am going to have a method here. So, I am asking for a class. That class is going to be a class A, open and close. I am asking for having a method. The method should be public. I do not have information about the type, so method. And what I am asking is, this is the only method. And according with this connection, I am going to call foo. And the only way that I can call a method is inside of another method, right? So what I am asking is, here, I am going to call foo. That is my source code. Now, in order to call foo, according with this, what I need is some kind of object from that class. So according with this, I have a variable local from the class B that is X. So I have a variable there and then I can use the variable, and then I can call the method, and that is exactly what is happening with the diagram. Guys, very, very important. Professor, you are telling us that here you have a variable X from the class B. That is composition, right? Or association. Composition and association are only with global variables. This is a local variable. No association, no composition there. Is just a local variable. We do not represent local variables in the class diagrams. The class diagrams represent call of methods, inheritance, implements, and global variables. Global variables, for instance, if I put here a global variable B, W, that W that is global, that one, needs that connection, because now I have association composition, aggregation composition between A and B, because of this one, not because of the local. If I go and put this new B here, outside of the method, BW equal new B, tell me, that is a white diamond or a black diamond? Why is black? I agree with that, it's black. Why? There is any way that W is going to be null? And hopefully you agree with me, no. It's going to be created immediately. Always is going to have a value because you have this new here. Wait, so what happened if I delete this new from here? What happened if I have only this BW? It is null. In fact, according with this program, W have a value in some point. In this program, is null, never have a value. There is no source code here giving a value to W. Here, when I remove the equal new, also, I need to remove this. Black diamond, white diamond, black diamond, put the new, mandatory. White diamond, you can have your variable, is null. Whatever are you going to do with that, it can wait. Calling the method, the arrow, one direction. A is calling a method in B. I do not have B, so I do not know what is going to happen with B. So far, the connection is in only one direction. Clear, easy. Okay. So this is only between two classes. I want to be sure that this is clear. Tell me this. A diagram from this full bar tutorial online, the best of the online tutorials. It is correct, this class diagram? Are you browsing online and you found this diagram and it says it's a UML class diagram? So you're going to review it, good or bad. Professor, is the solution for our homework. It's online, and the signature is the best programmer ever in the best company ever. Is correct? Okay. Number one, and I am going to start with the easy things. Number one, easy things. You need to separate the name of the classes. Like here. Number two, the important thing is missing all the information about Public, private, and protected. No one have anything about public, private, and protected. 3. What is this? I mean, the only thing that I know is that this diagram was done with PowerPoint. What is that? A black triangle? You have black diamonds, but not black triangles. Oh, it's like inheritance. Like. This variable here, you have 2 options in the diagrams in order to represent variables. Option number 1, you put the variable here. Option number 2, you put a relationship with diamonds. You do not use both. If you have a class public class foo, and this public class foo is going to have a variable var x. That's it. That is my class. Can you create a class diagram for that class? And hopefully you're going to do like, well, you're asking me to do a class, and therefore it's going to have those 3 elements. And according with your diagram, the class name is foo. And according with this source code that you are giving me, there is a variable x. The type for the variable x is var. We're going to talk more about how to represent the data types, but that is an information. Now, is public or private according with the source code? Because it should be private. It is private. A variable without private, private, or protected is sure friendly, which means public. Public in the package, public in the same folder. It's not going to be public in other folders, but without anything there, it's public in the same folder. That corresponds to a plus in the diagram. This is the diagram for this source code. Wait, but really, that is option 1. Wait, but you are telling me in that source code that you have a class foo, and you are telling me that you have another class var. Because it's uppercase, right? Uppercase, the name is a class. So I can understand that I have 2 classes, one class foo and another class var. Tell me, because of this global variable, there is a connection between those 2 classes, foo and var? And if so, what is the connection? We are calling a method. We are inheriting aggregation. The value for x is null. So we're going to have diamonds. Where is going to be the diamond? In foo or in var? Why diamond? Right of left. Together with foo, together with var. Foo is the owner, right? A diamond connected with var. When you use the diamond, when you have a relationship, something that you can do, something that is optional, something that you need to know. This line here, the diamond and the line is representing this global variable. You can even put here a name. If you want mandatory to use the name x, you can put the name here. X is the name of the variable that you need to create in order to have this connection, aggregation between foo and var. This is my option B. Both work. Both represent a class that have an attribute, and that attribute is from the type var. The important thing is you use one or the other. You cannot put this here, because then what you are telling me is that there are two variables var, and there are two with the same name. If you only do the copy paste, is one or the other. You put the relationship or you put the value. Obviously, if you have a variable y and it's an integer is not a class. Int is not a class, so you need to put the variable. When you have the data type, primitive data type, it's mandatory to put this here in the box. But when the data type is a class, it's up to you, according with the scenario, if you put the relationship or you put the text, but do not put both, one or the other. So, as you mentioned in the chat, this is this twice. Nope. Remember, mandatory, the idea in object-oriented, private your attributes, information hiding. So when you have the relationship, composition, aggregation, the assumption is they are private. The variable is private, and you're going to have public methods to access the information, the getters and the setters. Okay, you need the lines. Even if you do not have variables or you do not have methods, it's useful to know that they are empty. It's like a confirmation of there is nothing there. For instance, here, it could be something like this. So no variables in these classes, the attributes are empty, and there is one method there that is the overriding of the one in the class parent. Good. So be careful with this. Use the software that you know from your previous classes, ASTA or something else. Be careful to do not do class diagrams with PowerPoint. This is the result, and they look bad. Anyway, this is wrong. Something like this, and that is my goal for you. Tell me, if I give you this class diagram, can you explain what is happening here? Can you start working with the programming, use reading this? Can you imagine the graphical user interface here? There is a graphical user interface. Do we know that, just reading these things? My assumption of what you are doing is, number one, the first thing that we can do is check where is the main, because that is going to be the beginning of everything. So we can locate the main, and thank you, is here in this class. Tell me, why the main is with this underline? What does it mean when you have a method or a variable with a line below? Just guess. Static, correct. When you have something with this underline, the reason because the main is with the line is because it's public, static main. The public, the plus, the static, the line, and everyone else is there, the void and the parameters. Okay, so the main is there. That is the important class. So universe is going to be this class at the center of everything. And did you notice the diamonds? Did you notice 1, 2, 3 diamonds? Diamonds, composition association, having. What is going to have my class universe? We just follow the lines, and it's going to have something, an object tutor, it's going to have an object assessor, and it's going to have an object companion. And reading the names of the classes, I have no idea what they are. Like what? However, if I follow the lines, tutor, I have no idea what it is, but the parent is panel. Assessor, I have no idea what it is, but the parent is also panel. And companion, I have no idea what it is, but the panel is also panel. That means that maybe universe is going to be something, and inside of that something, there are going to be 3 panels. What is going to be the content of the panels? I don't know. The classes should be doing something, but there are going to be 3 panels. Moreover, here, I am calling a method in a class J slider. I am calling a method. Which method? One method add, and that method is going to put a slider here. Guys, having with the panels and calling a method with a slider, both are going to put something inside of the graphical user interface. Having composition is not about physically having something inside. It's about a relationship between classes. It's a relationship of a global variable, or it's a relationship with calling a method. And you can achieve having inside of the graphical user interface something draw, even though you do not physically have the element inside. You do not have this connection of having. We're going to work with this, with the Pacman, but just be aware. You can draw something inside of here, like an element, like the slider, and you do not have it, because you do not need to have global the variable. You can have the variable local. And remember, if you have the variable local, like in my example here, I have a variable, but this local. The relationship is just an arrow, not aggregation composition. Similar here. Anyway, okay, the tilde is protected, yes. Good, so I have a slider. Moreover, I have inheritance here from JFrame. This universe, the one that have the panels and the one that have the slider, is an specialization of a JFrame. So this guy is going to have this maximize, minimize, and close. It's a frame, it's a window. And inside of the window, I am adding panels. And inside of the window, I am adding this slider. I can continue reading, and then there are some labels. And the labels, I am just calling methods. Twice for this one. There are going to be 2 labels here. I do not have it, but I am calling methods in label to draw something there. They are going to be local variables. Here, it's going to be a label also. I do not know what is happening. I do not know the distribution, the graphical distribution. But the structure, what I am going to have is something like this. Moreover, action listener, inheritance and interface for this guy. Something here is going to happen when I interact with elements inside of this panel, because that one have a connection with action listeners. Action listeners triggering events using graphical elements, right? Maybe there is a label, and when you click the label, something happens. I have 2 labels. Talking about that, I have another implement here, another listener, change listener. That guy is connected with the slider. Change listeners are the ones that you use for the sliders. We need to talk more about the full structure, but my goal today is you know how to draw classes, you know the 3 types of connections, and somehow you should be able to more or less understand what is happening or what is the proposal for the programming of something like this. It's not related with the things that you have reviewed before. It's another project. But hopefully you saw the diagram and it's like, okay, at least we know where to start or what is the global idea here. Any question regarding what is on the screen right now, guys? I have a class tutor. That is this one. According with this, I have this variable. Question, that one is the name of a global variable, yes or no? For your quiz, HTML paint is a global variable, yes or no? Just look into the diagram. How do we know? Okay, rule. The only way that that name could be a global variable is if we have diamonds. The only way, the only relationship that model global variables, attributes, are composition and aggregation. If you do not have that, there are no diamonds there. Maybe it's a local variable. Maybe it's the name of a method. Whatever. It's not a global variable because there are no diamonds. So true and false, that one is a global variable. No, that cannot be global variable because there are no diamonds. That one can be several different things, and we're going to review all the options. The only thing that I want to ensure that you have clear is not a global variable, cannot be a global variable because there are no diamonds. And answering the question in the chat, this X and this X. And just ignore them. Screenshot from the tool, and those are the points in which I can move the arrow. So it's not part of the UML diagram. It's because I am using a particular tool and the screenshot capture the X's. So they should not be there. They are the points in which I can draw the connection. Good. Now, we know how to do class diagrams. And close the parentheses. My point is, guys, if I want you to help me and move from the requirements of the Pacman to the classes that I need for the game, how many classes do I need and how they are connected? Now, in order to facilitate things, you know what? I would like to implement a Pacman, but really, I do not care about all the details. For instance, I don't care about the maze. The only thing that I want is a grid instead of the maze. Second, I don't really care about the Pacman as an oval with all this animation. My Pacman could be this yellow square, and the only thing that I want is to move the square using the arrows. My ghost, I do not want 4. I do not really need 4, but what do I need to create? 1 at least. And one that move randomly, as you notice, is just moving somehow around. And well, the other thing is the pills. And if I can create 1, probably I can create more. So what do I need to do in order to have a program, my Pacman Lite, like this, a window with a grid, with the possibility of moving a yellow box with the arrows, with someone moving randomly, the red one, and other elements that I can add, like the pills. How many classes, how they are connected in order to then do this program? Can you think about it? That is my homework. Again, nothing to submit. We're going to do this in the next lecture. Thank you, guys.